When we react to create compounds which end in ate or ite, the balancing can get a little bit more tricky. For this lesson and the next lesson, which looks at more advanced balanced equations, we are going to be using the box method. If you need a little refresher, if you go on to lesson 6 and have a go using that method there before moving on to this lesson. Now, there are a couple of rules that will make this super easy for you to do. The first one is extremely important. If we have group ions, we want to use page 8 of the National 5 Chemistry Data Booklet to put brackets around those group ions, just the exact same way when we are writing formula for compounds which end in ate or ite. We always put brackets around them. Number 2, if you have these group ions in brackets on both sides of your equation, so that's the reactant side and the product side, we keep them in the brackets. If we do not have both group ions on either side of the equation, we have to take them down into their individual elements. Step number 3, we need to remember what Santa says. He says ho ho ho. So we need to do all other elements, then hydrogen and oxygen last, and then we will just do the box method, going down our shopping list and remembering to go over it twice, just like the previous videos. This example, we have sodium sulfate. We're going to put a box around that, plus barium chloride, again, put a box around that entity, which react together to produce sodium chloride and barium sulfate. Again, remember from video 6, we must put boxes around our entities. The first rule of doing the intermediate balanced equations is because we have more than 3 elements found in our compounds, we have to use page 8 of our chemistry data booklet to identify the group ion. When we use that, we can see that we have sulfate, which is SO4. So we're going to put a bracket around that on the left hand side. And what we can see is on the right hand side, we also have an SO4. So we make sure we put a bracket around that. What we have to do next is we write our shopping list. Remember, Santa says ho ho ho. So all other elements and then hydrogen and oxygen last. So we have a sodium. This time we're going to write our SO4. It's not an individual oxygen atom, so we're going to keep that in a bracket. We've got our barium, Ba, and our chlorine, Cl. We're going to mimic that on the other side. How many sodiums do we have on the left? We have 2. How many sulfates do we have? We have 1. There's no number directly after the bracket. How many bariums do we have on the left? We have 1, and chlorines, we have 2. On the product side, how many sodiums do we have? We have 1. Sulfates, there's no number directly after the bracket, which tells us we have 1. Bariums, we have 1, and chlorines, we have 1. So now what we want to do is we want to go down our shopping list and check to make sure that they're balanced. Sodiums. On the left hand side we have 2, on the right hand side we have 1. They don't balance. What do we do to 1? To get to 2, we multiply by 2. So we put a big 2 outside the box of the sodium chloride. How many sodiums do we have inside the box? We have 1. 1 times 2 is 2. How many chlorines do we have inside the box? We have 1. 1 times 2 is 2. The sodiums balance, so we can tick them off. Sulfates, on the left hand side we have 1, on the right hand side we have 1. They balance, so we can tick them off. Bariums, on the left we have 1, on the right we have 1. They balance, so we can tick them off. Chlorines, on the reactant side we have 2, on the product side we have 2, so we can tick them off. We double check that everything's still balanced. It is, so that's us completed our balanced equation. Worked example number 2, we have silver nitrate plus barium chloride, which reacts to produce barium nitrate and silver chloride. So we have to remember to put boxes around the entities. And because we have got 3 elements which are present in an individual compound, we have to use page 8 of our chemistry data booklet to identify the group ion. Using page 8, we can see that we have nitrate, which is our NO3. On the left hand side, we put it in a bracket, and on our product side, we have already got that in a bracket. We write our shopping list. Remember, Santa says ho ho ho, so all other elements, then hydrogen and oxygen last. Silver has the formula Ag. The nitrate, even though it contains oxygen, is not an individual element, it's a group ion, so we keep that together. So we've got our NO3. Barium is Ba and chlorine is Cl. We mimic that on the other side. How many silvers do we have on the left? We have 1. How many nitrates do we have? We have 1. There's no number directly after the bracket. How many bariums do we have? We have 1, and chlorines we have 2. On the product side, how many silvers do we have? We have 1. Nitrates, this time we have 2. There is a little 2 after the bracket found on the right hand side of the page. Barium we have 1, and chlorine we have 1. So now we're going to check our shopping list. On the left hand side, how many silvers do we have? We have 1. On the right hand side, how many do we have? We have 1. They balance, so we can tick them off. Nitrates, on the left hand side, we have 1. On the right hand side, we have 2. These don't balance. What do I do to 1 to get to 2? I multiply by 2. So I need to put a big 2 in front of the silver nitrate. Remember, we don't put any numbers inside the boxes. How many silvers do I have inside the box? I have 1. 1 times 2 is 2. How many nitrates do I have inside the box? I have 1. 1 times 2 is 2. My nitrates balance, so I can tick them off. Bariums, how many do I have on the left? I have 1. On the right, I have 1. They balance, so we can tick them off. Chlorines, how many do I have on the left? I have 2. How many do I have on the right? I have 1. Those don't balance. What do I do to 1 to get to 2? I multiply by 2. So I put a big 2 in front of the silver chlorides. How many silvers do I have inside the box? I have 1. 1 multiplied by 2 gives 2. How many chlorines do I have inside the box? I have 1. 1 times 2 is 2. My chlorines balance, so I can tick them off. Remember, we have to check our shopping list twice, so we go back up to the top. How many silvers do I have now? I have 2 on the left hand side. How many do I have on the right hand side? I have 2. They balance, so I can tick them off. Nitrates balance, barium's balance, and chlorine's balanced. That's us completed the balanced equation. This is the last worked example that I'm going to work through with you. And in this reaction, we have zinc carbonate reacting with hydrochloric acid to produce zinc chloride, water, and carbon dioxide. We're going to have to use page 8 because we've got a group ion on the left hand side of the equation, which is our carbonate. So we put a bracket around the CO3. What's different about this one is that we don't have a CO3 on the product side. As a result, when we're writing our shopping list, we have to make sure that we break the carbonate ion back down into its elements. Remember, when we are doing our shopping list, we have to think about ho, ho, ho. All other elements, then hydrogen and oxygen last. So when we're writing our shopping list, we'll start off with zinc, which has the chemical symbol Zn. Carbon, which is C. Chlorine, which is Cl. Hydrogen, which is H. And oxygen, which is O. Remember, we do all other elements, then hydrogen and oxygen last. We mimic that on the other side. We're going to write down how many zincs we have on the left. We have 1. Carbons, we have 1. Chlorines, we have 1. Hydrogens, 1. And oxygens, 3. On the product side, how many Zns do we have? We have 1. Carbons, we have 1. Chlorines, we have 2. Hydrogens, we have 2. And we have to be careful with the oxygens. We have 1 in our water and we have 2 in our carbon dioxide. 1 plus 2 equals 3. So let's double check our shopping list to make sure everything is balanced. On the left hand side, how many zincs do we have? We have 1. On our product side, we have 1. They balance, so we can tick them off. Carbons on the left, we have 1. Carbons on the right, we have 1. They balance, so we can tick them off. Chlorines on the left, we have 1. Chlorines on the right, we have 2. Those don't balance. What do we do to 1 to get to 2? We multiply by 2. So we put a big 2 outside of the box of the hydrochloric acid. How many hydrogens do we have inside the box? We have 1. 1 times 2 is 2. How many chlorines do we have inside the box? We have 1. 1 times 2 is 2. My chlorines balance, so I can tick them off. Hydrogens, we now have 2 on the reactant side. We have 2 on the product side. They balance, so we can tick them off. And oxygens on the left, we have 3. Products, we have 3. Therefore, they balance. We can tick them off. We double check that everything on both sides are balanced, which they are. So that's us completed the balanced equation. So here are 3 examples for you to have a go at. You must remember to put boxes around each of the entities on both sides of the equation, and you will need to use page 8 of your chemistry data booklet to put brackets around the group ions. So if you want to pause the video, you can have a go at these, and when you're ready, if you just press play, the answers will come up on the screen. I'm going to talk you through 2 past paper questions which look at intermediate style balanced equations. If you want to have a go at them, you can pause the video, have a go, then press resume, and I will go through the answer. This first past paper question is from the National 5 2013 specimen paper written for A Part 1. A student investigated the reaction of carbonates with dilute hydrochloric acid. In one reaction, lithium carbonate reacted with dilute hydrochloric acid. The equation for the reaction is balance this equation. The first step, we have to put boxes around the entities. What we can see is we have got a compound which has 3 elements, so we're going to have to use page 8 of our chemistry data booklet. We can see that the CO3 is our carbonate ion, so we have to put a bracket around that. Because we only have a carbonate on the reactant side, we're going to take that group ion into its individual elements. So when writing our shopping list, we need to remember ho, ho, ho. So we do all other elements, then hydrogen and oxygen last. So we have lithium, which is Li, carbon, which is C, chlorine, which is Cl, then we do hydrogen, and then oxygen last. We mimic that on the other side. How many lithiums do we have on the left? We have 2. How many carbons do we have? We have 1. Chlorines, 1. And hydrogens, 1. How many oxygens do we have on the reactant side? We have 3, so we pop that down there. Lithiums on the product side, we have 1. Carbons, we have 1. Chlorines, we have 1. Hydrogens, we have 2. Now remember, with the oxygens, we have got 2 inside the box for the carbon dioxide. We've got 1 inside the box for the water. 2 plus 1 equals 3. So we start at the top of our shopping list and make sure that they are balanced. How many lithiums do we have on the left? We have 2. How many do we have on the right? We have 1. Those don't balance. What do I do to 1 to get to 2? I multiply by 2. So I put a big 2 in front of the lithium chloride. How many lithiums do I have inside the box? I have 1. 1 multiplied by 2 gives 2. How many chlorines do I have inside the box? I have 1. 1 times 2 is 2. My lithiums balance. I can tick them off. Carbons, on the left I have 1. On the right I have 1. They balance, so we can tick them off. Chlorines, on the reactant side we have 1. On the product side we have 2. Those don't balance. What do I do to 1 to get to 2? Well, we multiply by 2. So we put a big 2 in front of the HCl. How many hydrogens do we have inside the box? We have 1. 1 times 2 is 2. How many chlorines do we have inside the box? We have 1. 1 times 2 is 2. My chlorines balance, so I can tick them off. Hydrogens on the left, we have 2. Hydrogens on the right, we have 2. So they balance, we can tick them off. Oxygens on the left, we have 3. Oxygens on the right, we have 3. We can tick those off. We have now completed our balanced equation. This question's from the National 5 2016, written 6B. In the production of the fertiliser ammonium phosphate, phosphoric acid, which formula is given as H3PO4, reacts with ammonium hydroxide as shown. Balance this equation. The first step, we must put boxes around each of the entities which are given in the equation. We can see that in many of our entities we have more than 2 elements, which means we're going to have to use page 8 of our chemistry data booklet. In the phosphoric acid, we have got a phosphate ion, which is our PO4, so we have to put a bracket around that. We have a look to see if we've got that on our product side, which we do, so we put a bracket around the phosphate ion, which is found on the product side. For the ammonium hydroxide, we can see that we've got 4 elements present there, so this one's a little bit tricky because we've actually got 2 group ions. We put a bracket around the NH4, and what we can see is we already have a bracket given in the balanced equation on the product side already. The hydroxide ion is OH, so we put a bracket around that, but what we can see is that is not found on the product side. So that hydroxide ion is going to be broken down into its individual elements. When we're writing our shopping list, we have to remember ho. We do all other elements, then hydrogen and oxygen last. So we have our phosphate, which is our PO4, our ammonium, which is our NH4, and then we have hydrogen and oxygen. We mimic that on the other side. How many phosphates do we have on the left? There's no number after the bracket, which tells us we have 1. Ammoniums, again, we have 1. The hydrogens we have to be careful with. In our first box, which represents our phosphoric acid, we've got a total of 3. In our ammonium hydroxide, remember we're breaking the hydroxide ion down into its elements, so we've got 1 in there. 3 plus 1 equals 4. How many oxygens have we not accounted for? We've just got the one which was found in the hydroxide. On the right hand side, how many phosphates do we have? We have 1. How many ammoniums do we have? There's a 3 after the ammonium ion, so that tells us we have 3. How many hydrogens do we have? We have 2. And how many oxygens have we not accounted for? We have got 1. So we start at the top of our shopping list to balance them out. How many phosphates do I have on the left? I have 1. How many do we have on the right? 1. They balance, so we can tick them off. How many ammonium ions do we have on the left? We have 1. How many do we have on the right? We have 3. Those don't balance. What do I do to 1 to get to 3? We multiply by 3. So I put a big 3 in front of the ammonium hydroxide. How many ammonium ions do we have inside the box? We have 1. 1 times 3 is 3. How many oxygens do I have inside the bracket? I have 1. 1 times 3 is 3. How many hydrogens do I have inside the bracket? I have 1. 1 times 3 is 3. However, remember we still have the 3 hydrogens which are present in the phosphoric acid. 3 plus 3 equals 6. The ammoniums balance, so we can tick them off. How many hydrogens do I have on the left? I have 6. How many hydrogens do I have on the right? I have 2. What do I do to 2 to get to 6? I multiply by 3. So I put a big 3 in front of the water. How many hydrogens do I have inside the box? I have 2. Multiplied by 3 outside the box. 2 times 3 equals 6. How many oxygens do I have inside the box? I have 1. Multiplied by the number outside the box, which is 3. 1 times 3 is 3. My hydrogens balance, so I can tick them off. How many oxygens do I have on the left? I have 3. Oxygens on the right, I have 3. They balance. I double check that everything has ticks next to it, which it does, which means we have balanced this equation.